All right, we are ready to start a brand new topic. So we are looking at topic 4 in 7th grade math today, and we are going to be exploring rational numbers and how the rules for adding and subtracting those. So make sure that you complete your bell work problems. Right up here, and we will go ahead and get our topic and our objective listed up here. So your learning goal for today is I can classify rational numbers and find opposites. We will also be taking a look at absolute value today as well. So you can take your topic and our objective here and turn that into a question that could be something like, how do I classify rational numbers? Or what are the different types of rational numbers and how can I use opposites? Something like that. So as we are looking at this together today, as we think about these different categories of numbers, I want you to think about where you live. So thinking of this map of the United States, that narrows our focus a little bit. In the United States, we are on the North American continent, but we're also in the country, the U.S. We also live in the state of Missouri, but we're in the city of Kansas City. So one location that has lots of different levels of ways of naming it. So that's exactly what we're doing with our numbering system here today. So first, we're going to look at 4 different levels. So our big box here, we are going to start by listing all the numbers in here as rational. And hopefully when you see the word rational, you notice the root word ratio, and that tells you exactly what it means to be a rational number. Rational numbers are ones that can be written as a ratio. So we spent all of our first quarter working with different ratios, so we all know that a ratio can be written as a fraction. So we're looking at numbers that can be written as fractions. So here are some examples of rational numbers. If it will let my pen work, there we go. Negative 21 fifths. This is already written as a fraction or as a ratio, so I know it's rational. And as long as I can write a number as A over B, and A and B are not 0, then it's rational. Another example of a rational number would be negative 6 and 25 hundredths. Although this is currently written as a decimal, it could be written as a fraction or a ratio, so this would be considered rational. In the same way, if I have negative 7 tenths, this is currently written as a decimal, but it could be written as a fraction, so that makes it a rational number. 1/2 would be another example of a rational number. 19 fourths would be another example. Let's consider 5 and 1/3. How can I know for sure whether or not this is rational? It's currently a mixed number, but I could write this as the improper fraction 16/3, so we would say that this is rational as well. So let's look at our smallest category of numbers that we'll be considering today, and those are our whole numbers. So our whole numbers are a smaller set of rational numbers. So all of my whole numbers can be written as a fraction, such as 0. 0 can be written as 0 over 1. Other examples of whole numbers include 1, 2, 3, and so on. And then in between my category of rational and whole numbers, I have another category called integers. And integers would be all of my whole numbers. Notice that the whole numbers category is inside of integers. So all of my whole numbers are integers. But integers also includes all the whole numbers opposites. So the opposite of 1 is -1. The opposite of 2 is -2. The opposite of 3 is -3, and so on. So all of these numbers, integers, whole numbers, these are all different kinds of rational numbers because they can all be written as a fraction. So now that we have categorized some together, I want you to try to categorize some of these on your own. So using this list here, you are going to place each of these numbers in every category in which it fits. So I could use the same number and I could place it in all 3 categories if it fits. So go ahead and pause the video while you place all these numbers, and then you can check them out with us. First up, we have 1 and 1/6. 1 and 1/6 would not be a whole number. It's not 0, 1, 2, 3, 4, 5, 6. It's not my whole number, which means it's also not an integer because my integers are my whole numbers and their opposites. So this is not an integer, but it definitely would be a rational number because I can write it as a fraction or a ratio. Okay, I have the number -125. Not a whole number because my whole numbers are never negative, but it would be an integer. And it's also rational because I could write it as a ratio by putting -125 over 1. Let's consider 0. 0 would be a whole number, which means it's also an integer. And it's also a rational number because I can write it as a fraction, 0 over 1. -7 is not a whole number because it's negative, but it is an integer. And it's also a rational number because it can be written as a ratio or a fraction, -7 over 1. -2 and 1/4, not a whole number. It's not 0, 1, 2, 3, 4, 5. Not an integer because it's not the opposite of a whole number, but it is a rational number because it can be written as a fraction. 2/3, not a whole number, not an integer, but yes, a rational number. -1/10, not a whole number, not an integer, but certainly a rational number. I could write this decimal as a fraction, -1 over 10. The number 13 is a whole number, which makes it also an integer, and it's also rational because I can write it as a fraction. -3/4, not a whole number, not an integer, but yes to rational number. And finally, 1 and 9/10 is not a whole number, not an integer, but yes to rational. Because I could write that as a ratio. So ask yourself, to which sets of numbers does -1 and 3/5 belong? Where would you place this? Would it go in all 3 categories, just 1, or maybe 2 of them? Now, one thing to consider is the version in which a number is written. So one of your friends says the number 4/4 belongs only in the category rational numbers. And it for sure should go in the rational numbers category because it's currently written as a ratio. But another friend says it belongs in each category. So is 4/4 also a whole number and an integer? And how can we decide? Take a second to jot down your response. You're going to give me your answer to this question in Schoology. So take a second to jot down what you think, and then I will let you explain yourself. All right, the second part we are looking at today is called absolute value. And absolute value just means the distance from 0 on a number line. So I'm going to show absolute value using a set of bars like this. So if I want to find the absolute value of the number 2, then I will place that number inside these absolute value bars. And what I'm asking for, if I say what is the absolute value of 2, is how many units is the number 2 from 0 on a number line. So obviously if here is 0 and this is 2, 2 is 2 units away from 0 on a number line. An absolute value is that simple. However, sometimes we're looking at negative numbers. So if I'm looking at the absolute value of -2, I still want to know what is the distance from 0 on a number line. And a distance is always a positive value. So the absolute value of -2 is +2 because I'm measuring a distance, and this is a distance of 2 units. So let's look at a couple examples. We're going to try to compare, meaning we're going to use less than, equal to, or greater than symbols to complete each of these statements. So when I say the absolute value of 5, I'm asking myself, how far is -5 from 0 on a number line? And of course, it's 5 units from 0. Whereas the absolute value of 3 is 3. And I know that 5 is greater than 3, so I need the greater than symbol. If I'm looking at the absolute value of -7 6/10, I'm asking how far is -7 6/10 from 0 on a number line? Well, it's 7 6/10 units away, and 6 is 6 units away from 0. So the absolute value of -7 6/10 is greater than the absolute value of 6. On our third example, the absolute value of -1 is 1, and the absolute value of -3 is 3, because I'm saying how far is -3 from 0? What is the distance? And a distance always has to be positive. So the absolute value of -1 is less than the absolute value of -3. All right, let's consider fractions for a second. I'm looking at the absolute value of -1/2. And that distance from 0 is 1/2. The absolute value of -1/4, or its distance from 0, is 1/4. So I need to consider what's greater. Is 1/2 greater than 1/4? Yes, I would rather have half of the pizza than just a fourth of it. So it is greater. The absolute value of 3 1/10. 3 1/10 is 3 1/10 units from 0. And -3 1/10 is also 3 1/10 units from 0. So these absolute values are equal. And finally, 4 1/2 is 4 1/2 units from 0. -9/2 is 9/2 units from 0. But if I can't compare these unless I put them in the same form. So let's either change them both to mixed numbers or both to improper fractions.